Hey everyone, it's me, Elle, and today we're going to try a bit of an interview format. There was a guest that I really wanted to chat with a bit about model testing. That's something that we've been looking at over the last couple of videos. You might remember that in my last video where we were doing a behavioral test, I mentioned that there was a blog that had inspired me. And so here we have the author of this blog, Jeremy Jordan. So Jeremy is a data scientist, and maybe we can start. Can you just kind of let everybody know like a little bit about what was the blog that we're talking about?
Yeah, so I had read a paper from ACL this year. I think it was actually the best paper award there that covered behavioral testing of NLP models. And I thought it was a really fascinating concept. So I wanted to kind of dig into the topic of testing for machine learning systems and kind of, aggregate my own thoughts and really compare and look at what's different between testing traditional software systems and machine learning systems, and what are some of the unique challenges associated with testing machine learning systems.
Yeah, and it kind of, I think it was the first time in your blog and also in the paper, which I went back and read. And the papers are really, I mean, it's really worth reading if you work on any type of NLP systems, I think. And it kind of goes into like tests that go way beyond just understanding, how does the accuracy of, a model change when we update some parameters, or, how does it do on some benchmark? It goes beyond that to like trying to understand and get some intuition about what kind of rules has this model internalized, and does it behave in ways that you want it to? And I think there was an example in your blog that you did, which was about like an apartment data set, right? And it was like, you want to check that if you make the apartment smaller, that the model predicts that it should get cheaper, not more expensive, but that it might have learned smaller apartments are more expensive because of those tend to be downtown and, in an urban area and pricier. So that I felt like I'd heard that before, ideas like that before, but I had not really connected like, oh, wait, what if we just did this automatically as part of our testing suite? So I thought that was pretty cool.
Yeah, I really like the kind of systematic approach towards describing all of the behavioral attributes of a model. So, these evaluation metrics can give us kind of a summary of performance. But I think model testing is all about extracting out, here are all the behavioral attributes and characteristics that we care about, and identifying the model's performance and kind of the logic that the model learns for each of these very specific attributes.
Yeah. So why don't we actually take a step back and could you tell people a bit about yourself? I'm interested to hear about like how you got here and what you do at work. What kind of projects do you work on generally?
Yeah, sure. So I work on machine learning systems at Proofpoint. Proofpoint is a cybersecurity company. So the models that I'm developing are all about detecting malicious content in our customers' email data, email and kind of social media data, so that we can protect them from threats and cyber attacks.
Mm-hmm, mm-hmm. And what are your interests generally in data science and software?
Yeah, so I got into machine learning basically because I was reading about all of the new capabilities and like cool things people were using machine learning for, and I kind of looked at the field from the outside. I come from an engineering background, but I didn't study machine learning in school. But I was looking at the field and I was like, this is way too cool for me not to be a part of. So I kind of embarked on an independent study to teach myself machine learning and join the field.
Oh, that's basically exactly what I did. I was like, I have to get in here. Too much cool stuff going on. And you've kind of created this blog, right, that has a lot of your learning looks like it's translated to blogs, right?
Yeah, I found that to be a really effective tool as I was learning because, this was an independent study. I wasn't learning in like a structured school environment. So forcing myself to take what I was learning and write that down onto a blog post kind of in my own words there's a really good forcing function to really check my understanding and make sure that as I'm learning about these things that I actually understand it and can explain the concepts to people.
Cool. And you also work on some open source projects, right?
Yeah. I love open source in general and just the idea of collaborating openly and transparently on projects. Most recently, I've been pretty involved with PyTorch Lightning. I had started using the tool for a side project that I was working on, and kind of wanted to make some improvements to the tool. And that's the beauty of open source is you can just file a issue on GitHub or whatever source control you're using, and make a suggestion, and then also submit the feature that you have in mind. So I had started submitting some features and improvements to the library, and then joined on PyTorch Lightning as a maintainer.
And just for anybody who might not be familiar with PyTorch Lightning, what is the project?
So it's an attempt to simplify the training of PyTorch models and really separate the engineering code that goes into training models from the kind of research code of how do we construct these models and define them to interact with data. So it does things like the main thing it provides you is a really robust train loop that you can then, you take your model, which you take a PyTorch model, you adapt it to fit us, an interface that we expect in PyTorch Lightning, and then you get this kind of trainer for free that lets you do things like training and distribute it across multiple GPUs and automatically log out to experiment tracking servers, kind of all the engineering code that you would want to implement, but the code that would kind of be boilerplate across projects.
Oh, cool. So from looking at, training and maybe some of the infrastructure around training, so why testing? So this blog that, it looks like it got a lot of traction online and it resonated with a lot of people. So why is testing an issue? Maybe you can just kind of give us the lay of the land.
Yeah, sure. I think testing is an issue because evaluation metrics don't tell us the whole story. They are, by definition, summary statistics. So we can get an idea generally of, is this model performing well or not, but we don't have a way to identify failure modes of that model in a kind of systematic way unless we do some type of testing. And in machine learning systems, we're not just training one model, deploying it, and leaving it be. We're going to deploy a model, collect data from that deployed model, and use that to train additional models. So we're making changes to the model that's being deployed, and we want to make sure to prevent behavioral regressions where the model performance might decrease on a subset of users or feature space. And we want to be able to identify when that can happen and prevent that.
Yeah, I could think of a lot of times I've worked on models, that you just have this sense that you have utterly no idea what features it's going by. And I tend to be very suspicious of people that are absolutely certain of like, oh yeah, it's just, I know what features it cares about. It's like, it can be really hard to tell without being systematic about evaluating it. And I remember a lot of projects where I've tried to like kind of at the end of it, figure out, okay, does it really underperform in a subset? Have I missed anything? But it was always like something that I had to like hand code, and it was not scalable or sustainable in any way. And, and in that way, I don't know how rigorous it can be. One thing before we go any further is just for anybody who might not know, can you talk quickly about what is a failure mode and what's a behavioral regression? We have total range of folks, I think, who listen to my channel.
Yeah, sure. So a failure mode basically describes a scenario in which the model does not perform well. So for example, you might have a failure mode for an image classifier in low lit conditions. When if we didn't include images with low lighting in the training set, but you deploy a model and it's now on thousands of people's phones and they're taking photos in low light environments, it might not perform as well. And so that can be, a failure mode of that model. A behavioral regression would be basically a decrease in performance on a specific region. So it might be a behavioral regression into a failure mode of, we used to be good at classifying images in low light, but then we shipped the model improvement, which, the overall metric improved, but all of a sudden now low light condition photos are giving all sorts of weird results.
Cool. So where are we kind of in the state of the art of, understanding failure modes of models and preventing regressions, and in kind of model testing, what is the state of the art?
Yeah. So, when I think of state of the art, I think back to like that paper I mentioned in the beginning. That was kind of an inspiration for that blog post. This is a relatively new paper. It came out this year, discussing kind of a systematic way we can approach model testing and kind of, providing a framework of the different types of tests we can run across our data set. When we look out into industry, I think a lot of people are more focused on just getting their models deployed and don't give a lot of thought right now to, kind of rigorously testing those models. Mature teams definitely do spend some time testing models. Like the recent example of Twitter's cropping algorithm that started failing, or people were trying to kind of poke and prod at the model and observe if it had any type of bias of protected classes that it was focusing on in that model. And the team that behind that model came out and said, yeah, this is something that we tested for as we were developing this model. And, they didn't provide many details around that, but it's one example of, deploying a model that is going to affect your user base and kind of running a series of tests to make sure that we're deploying models that, are fair and work well across all populations and all subsets of our user base.
Yeah, that was such an interesting, it was a really interesting dynamic. And I'll recap for anybody that wasn't familiar with this. There was a lot of interest in this topic on Twitter recently because of, I don't know how it got started, but there were a lot of users who were discovering that, Twitter will, if you put a big picture, it'll crop it to something, of the aspect ratio and it'll focus in on, perhaps some smaller part of the image. And it has some kind of algorithm that determines what part of the image gets, to be centered. And it was seeming to be ignoring faces that didn't look white. And I don't know precisely what the failure modes were, but it was quite replicable that, a lot of people would put a picture of, a white businessman and a black businessman stock photos, and systematically it would crop out the black businessman. And so here, this is a failure mode that really intersects with race in a way that, is really not acceptable for a platform that, serves people. And so there it's like, when it's low light, that's maybe the issue. It's like, okay, maybe we can live with this. We can deploy with this now that we know what this is. But, when it goes into race and gender and, other ways that people can be systematically disadvantaged by a system, it becomes a much more pressing issue. And so one of the things I thought was really interesting about this NLP check paper is that it started to suggest, like you can switch genders, of people in, an NLP data set, so put a very gendered name into a sentence and see, if I switch kind of the polarity of this name, if I switch all the Johns to Susans or something, does that really change the performance, of my classifier or my sentiment analysis, or what kind of words are predicted next. And so I see testing as, being able to do this rigorously and systematically, it does have a meaningful intersection with fairness. And so I suspect it's very important in that way too. And I have no idea what Twitter's team is like, but, you definitely have to wonder, like, was this something that maybe they did think of smart tests, but I can also imagine, having worked on machine learning projects, that like the tests weren't systematically, in place, that it might not have been run on the ultimate model that was deployed, or maybe it was run in a different environment or on somebody's machine. Like I have no idea, but it's not hard for me to imagine that even something well-intentioned, that they were thoughtful about it, because of the way things are implemented, it's quite easy to get something out that you don't really know what's going on under the hood.
Right. Yeah. And yeah, there are definitely high stakes environments where when we deploy models, we want to know that it's going to work well across all populations. Especially, if you look at deploying machine learning models in kind of highly regulated environments, like the financial industry. There was the model that was in charge of determining like credit limits for the Apple Card, which was another controversy, like, a couple months back, where a model was kind of systematically giving higher credit limits to men versus women. And, if there's a machine learning model behind that, that's definitely something that you want to have a test for and look at. Is our model invariant to gender? If we have the same exact profile for a man and we just swap that, gender to a woman, are we predicting that they can, have the same credit limit, or is there a noticeable decrease in the credit limit allowed for that person?
Yeah. So, I mean, in your experience, what kind of tools do people use to attempt to manage these kinds of, potential issues?
Yeah. So I think the kind of an ideal framework for testing models makes it really easy for us to select the data that we use to define model tests. If you compare software tests in general to the type of model tests that we're talking about here, one of the big differences is that these model tests are primarily defined by data or examples that we're feeding into the model, whether that's whether we're doing an invariance test where we're providing two examples and expecting the model output to be consistent between those two, or a directional expectation test where providing two examples and one of them is perturbed and we're expecting the prediction to go in a certain direction, or just kind of slicing our data set to a specific attribute and quantifying performance on that specific slice. Like if we're looking at the sentiment classifier and just selecting very short sentences and kind of quantifying our performance on that subset. Just being able to easily define these tests through data examples, and then have kind of like an easy way to, after these tests are defined, get that kind of model report card of here's how well your model is doing across all of these behavioral attributes and characteristics that you enumerated and feel are valuable to understand.
Yeah, I mean, it's so interesting how, much like how machine learning generally is, data matters as much, if not, and usually more than your code. And so in a way, your like coverage by a test of a model is very well defined by what is the data set that you use to test it. And if the test data set itself doesn't really cover a lot of the real world situations that it might, your model might encounter, then it's got pretty weak coverage. So it's very interesting. And I have to imagine that managing, and because I come from a perspective of versioning, but versioning and managing the data sets that you use for tests is also going to be a bit of an engineering challenge here.
Yeah, definitely. And I would love to see us enter the stage where, say we deploy a model and identify a failure mode in production that we hadn't anticipated. If that happens in, traditional software, one of the first things you do is you write a test to capture that so that you can prevent future regressions and, be able to make sure that when you deploy a fix for that, that fix is going to be stable moving forward. I'd love to see us kind of adopt the same practice for models of once we identify kind of behavioral regressions or failure modes of our models in production, let's take that and convert it to a test so then we can quantify that for all the future models of how well we're going to do in that situation.
Yeah, I mean, I have no idea if this is like, how feasible this is generally, but like, I would love to see, like, how there's model zoos, like a model zoo of tests. Like, these are a bunch of like, this is a test data set and some perturbations on it. And, you can just like check it out of something like GitHub and try it on your model, because people seem like every failure creates a new possible test, right? Every new failure you discover. Like on this Twitter example, I definitely wonder, like, had the way that people were running the test of making like a very long strip of a photo and seeing which end it crops, I thought was rather ingenious. And I don't know,
Yeah.
I really don't know how that originated, but like, if that's not a test that Twitter is running, it's really smart test, I think. So it's kind of cool that there could potentially be, because of there's only so many model tasks that we have, and there's a lot of overlap between them and even in different industries or, I mean, some of them are going to be fairly consistent, that we could have like a collection of, here are some good checks you might want to run. And we've already created a data set for it.
Yeah, I would love to see that, kind of here are, for the various types of NLP models that we build, here are good tests to run across that. For image classification models, here are good tests to run across that. And, even some more, I guess, niche data types like, DICOM files and healthcare models, having kind of a central repository where people can collaborate on tests so that we can make sure that all the models that we're deploying out into the world making decisions have been well tested and, we can quantify their behaviors.
Yeah, I mean, something that comes to mind is there's a possibility of overlearning to tests, but I think that is a challenge that can be addressed down the road. I'm just spitballing here of ideas.
Definitely.
So are there any projects that are ongoing now that you think are pretty inspiring or that you really like their approach?
Yeah. So the paper that won the best paper award at ACL and kind of introduced this concept had also released a library called Checklist, and that is just focused on NLP models. But it's a pretty robust library for testing those NLP models. And I'd love to see and thinking about what it might look like for kind of a more general purpose framework for model testing of kind of expanding just beyond NLP to other domains like image, multimodal, and tabular data. How do we build a model testing library that supports the whole variety of data and models that we're developing?
That's cool. And the last question I have is, do you have any plans to work on anything in this area?
Yeah, I've been kind of playing around with some like proof of concepts of, what this might look like. And I think it's something that has been exciting to explore, and I'm planning to continue building out these proof of concepts and kind of see if we can build this into a robust library. So yeah, I guess more to come on that.
Yeah, I mean, it's cool stuff. It's exciting, and I really enjoyed on the video where I was trying out like automating it. It's pretty fun. It's fun thinking of tests. It's fun automating them. And it's a cool area that like I have a hunch that lots of companies have things made like that they've created, to try to get at this, but like it's still kind of like an unstandardized, everybody tries it their own way kind of thing. And so I'm really excited for for maybe for this area to mature and to kind of maybe have some, we all come together and talk about, what kind of standards for testing do we want? And yeah, I'm excited, for the future development of libraries in this area and more papers. I also thought that paper was a really great contribution.
Fascinating.
Yeah. So anything else you'd like to share?
Yeah, I guess I would just encourage people that are in charge of deploying machine learning models into production and kind of deploying these models that are making decisions on behalf of systems to think about what are the types of tests that you would want to run on that model, and how would you kind of characterize the possible failure modes for that model. and yeah, think about what's going on in the space and start a conversation.
Great. Well, thank you so much for joining me. If people wanted to follow you, find out more, what's the best way to reach you?
The best way is probably through Twitter. I'm at Jeremy Jordan on Twitter.
Cool. I'll put a link. Follow his blog, give it a read. Thank you so much for joining us.
Yeah, thanks for having me.
All right. Bye, everyone.